To address some of the common errors from higher degree equations, try these problems. Okay, so first I look here and I'm going to try to factor 1 times negative 12 is negative 12. So I'm looking for two numbers that multiply to give me negative 12, combined to give me a negative 4. Okay, that would be negative 4 and positive 3, different signs. Larger number is negative. Now, because the leading coefficient is only a 1, I'm able to do x minus 4 and x plus 3. And this is where a lot of mistakes occurred today. We got to take this number and we got to evenly divide it by 2. So I'm going to take each one of those quantities, parentheses, and I'm going to set it equal to 0 and I'm going to solve, and I'm going to set it equal to 0 and I'm going to solve. These are referred to as factors. I add 4 to the opposite side. X squared equals 4. I'm going to have two answers. X equals plus or minus 2. On the opposite side, I subtract 3 to the other side. I should have two answers, but we can't take the square root of a negative, so this would be a no solution. So for this problem, we only have two real solutions, plus or minus 2. Let's move on to the next two problems. The vast majority of you did a wonderful job in using factoring by grouping in order to get to this point. So I was able to take out an x squared. I moved the x plus 4 over. I determined that negative 6 would allow me to get these back to. Everything's looking good. So both the front and the back contain an x plus 4. Then I have x squared minus 6. I'm going to take each one of those parentheses called factors. I'm going to set it equal to 0, and I'm going to solve. So I'll move 4 to the other side. And so one common misconception was if you get a negative answer, it can't be a solution. That's not the case. It's when you have x squared equals a negative. Here I'm going to add 6 to the opposite side. X squared equals 6. I'm going to have two answers. X equals plus or minus the square root of 6. Square root of 6 cannot be broken down using a perfect square. And we have the three answers to this higher degree equation. Let's look right now at our final one. So for this problem, oh, those numbers look ugly. I'm going to see, is it divisible? Let's see, can I divide by 4? I can. Can I divide by 4? I can. Okay, let's factor out a 4. And now when I divide by 4, I'm left with this trinomial, and I want to see, can I use factoring to solve it? If not, I'll revert to a quadratic formula. 1 times 75 is 75, so I'm looking for two numbers that are the same. They both have to be negative. We already recognize negative 25 and negative 3. So negative 25 times negative 3 is 75, and then negative 25 and negative 3 do combine to give you negative 28. So x minus 25, x minus 3, but here's where the mistake was made. Notice that we have a degree 4, so we have to split that equally. So it becomes squared and squared. I'm going to take each one of those factors. I'm going to set it equal to 0, and I'm going to solve. Okay, adding 25 to the opposite side, taking the square root, and I saw literally 50% of the people that made small mistakes here forgot I have a plus or minus 5. Adding 3 to the other side, and I have plus or minus the square root of 3. So there are my 4 real solutions for this example.